All right, so our next example is something I do fairly regularly. It's actually one of the ones on my list for learning a new language. I have several examples that I sit down whenever I go to learn a new language. I have some things that I've done a number of times in various languages, so I know the logic really well to learn the basic syntax. In the next lecture, next video, we'll be talking about some concepts, and I'll include the list of things, 8 things I always try to make sure I learn on a programming language as soon as possible. So I have a list of examples to kind of help me get going with that. And one of them is a tip calculator. It's a good standard in our society. I assume everybody's eaten at a restaurant and left a tip before, so you kind of have an idea of how that works, right? We tip based off a percent of the meal price. But I use this regularly whenever I learn a new language. This is one of my examples to go over the basic input-output on a new language. You might want to look for some programs like that. Tip calculator, Space Invaders is one I do a lot. There's a few, just a short list of things that I kind of put together that I know the logic for really, really well, and that cover the 4 or 5 things cover the key points of a language. So it covers all the points whenever I go to learn a new programming language. And tip calculators on that list. So you might want to keep that in mind and look for things that cover the basic concepts in a programming language, so that you have a list when you go to learn a new language. You can sit there and go through that list and get the basic idea of some stuff with logic that you're quite familiar with. So what does a tip calculator need to do? Let's see, we need a price of the meal. Oh, yeah, it's nighttime. The light is off center in this room, so I got to watch for my shadows falling. So we need the price. Percent. Then we have the formula, right? The amount we tip is going to be the price times percent. Right, our basic fill in the blank from you may have seen in the algebra class for a percent. We have some words. Blank of blank is blank. So like percent of some number is, I don't know, a value. Just make up another word there for that. It's another number thing. But percent of number is value. And then in math class, we can see those keywords, and of means multiply, and is means equal. And that's a good keyword to look for, because of doesn't have any synonyms in the English language. As complicated as English is, there's only one word that means of. So kind of a keyword. You may have seen that blank before, but basically we need to do that to get the amount of the tip. And then we'll have the total is going to be the price plus the tip. Is the basic idea of what we need to do here. Quick sketch of what the logic needs to do. In this simple example, I think the quick sketch is a decent order to work in. We have the naming requirement. Made it through the first example without getting too confused by that. We'll see how far this goes. Positional notation is a little confusing to work with, so we'll get to that point to express that. Might use, if it starts to get confusing, might come back and use it to express the point of the working version does not have to match the final version, right? We jump all over the place, back and forth as we're writing our code. We can write with different variable names than we're going to end with, right? The requirement is that we end and have, at the end, our code has to be in positional notation. The first time it wasn't so bad, but maybe when we start calculating, it's going to be a little harder to follow. So I'm going to do another UML use case diagram, Unified Modeling Language. So we have our user here. Our program over here. Let's do some color coding this time. Hopefully it'll show up in this dim light. But we need to get a couple inputs from the user. So coming from the user, we need to get the price and the percent. Let's do that. Remember, this is just a quick sketch. This is for you. This is for our benefit, organizing our thoughts. And please, please, please practice it on the easy ones. That way, when you get to something where you need it, you know how to do it. It just flows out naturally at that point. So once we have those, I'll make green. Yeah, green for some processing. We can set up our math, right? We're low on room, so I'm just going to use symbols. The total is going to be price times percent. This is for my benefit. I know what these symbols mean. Hopefully that all makes sense since you heard me just talk about that. And for our use case, the flow of the data is the user gives us the price and the percent, and both of those values flow into this processing thing. Then we'll have another process going on where total is going to be this value we just found, the amount of the tip, plus the original price. So once we find this value, that'll flow into that. And then do a red output. Red, that's orange. Here's red. And then we're going to output something like total is ... This is a planning stage. I don't have to write everything out here, just enough to organize the thoughts and kind of the basic idea of the use case diagram. Where the white piece goes is white. So our data flow, we'll get those from the user, flow into this processing symbol where we find the tip amount. Then we'll use the tip amount to find the total amount. Then we'll output the total amount. So notice how all these arrows are inside the processing oval. Then our output will come around and feed back to the user. It's kind of the idea of a use case there. And yeah, practicing it on the easy examples makes it a whole lot easier when we get to the hard examples. Especially with UML stuff, this is the international standard of communication between programmers, so you want to make sure you're going to want to know this stuff pretty well by the time we get to the end. So we're going to get these values from the user, do a couple calculations. We could do that as just one calculation. That wouldn't be hard. We just plus the price over here. Then we just have one line of calculation and then the output. So let's go over to Python and put this together. Our next example here, this is one that I often like to start with. It's a good basic thing that most people know how it works from our society, just living in our society. We saw on the board a moment ago, putting the plan together, we're just going to do a tip calculator this time. So again, we'll come in here and open idle. Slide that over a little. Don't want to do it one line at a time, so I'm going to open the text editor too. And again, we're doing positional notation, so I'm going to start here with writing out the key of the positional notation. And after this week, we won't spend as much time on every single piece of code writing out our notation. It's just, I selected the first week to cover positional notation. It can be a little confusing until you get used to it. Or if you're working for a particular company that uses positional notation, it's going to be the same every time. There'll be a company standard for how it's written. So let's see, what's a good one this time? Let's do 3 letters for the programmer initials. Then, well, we're doing class examples here, so let's do 2 digits for the class example number. Which for us, that's going to be 02 every time, right? We're in the second example here. 1 letter for the month. Letter for month. 2 digits for the day of the month. Put a date thing together again. And then I'll do a letter and a digit to represent a data type encounter. Again, just kind of making that up. So we'll see some variety in those through the examples. So, well, when this is a standard example, I like to start with the tip calculator, because most of us I assume everybody's been to a restaurant and left a tip before, so kind of have an idea of how that works. So we'll set up our variable here. So we need a couple variables, as we saw in the plan. We need the price of the meal and the percent we want to tip. And with this positional notation encoding scheme I just made up here, it looks like our variables are going to have our initials. So for me, CSF. This is example number 2. I'm making this video on March 18th, so M18. And, well, a meal price is a dollar amount, which means we'll have dollars and pennies, dollars and cents. So that needs to be a float, and this is going to be the first float we use. So, unlike we saw earlier, we can have this pre-built input function to ask the user how much the meal was. You can see from the little suggestion here saying what it's expecting. It's expecting us to pass some sort of prompt text in as an argument that it can use as a parameter as it carries out all the built-in stuff in the input function. So we'll pass in a string. How much was the meal? I'll do question marks this time because I did a colon last time. And then a space, that way where the user starts typing there's at least a space between there. But then, well, the user is going to give us something from the keyboard, which means it'll come in as a string. So we need to cast that into a floating point number. So we have this pre-built function called float. I'll wrap the input function in. So we're going to get the input and then cast it to a floating point number. And I'll just hit the end key to get my cursor over here at the end and do the closing parenthesis there. Home and end keys on your keyboard can be very useful. That goes to the beginning or end of the line. So home goes to the beginning of the line, end goes to the end of the line. And well, might as well mention, if you push Control Home, hold Control key and push Home, it goes to the beginning of the file. And holding Control and pushing End goes to the end of the file. Those are some very useful keys when writing code. So the second variable we will need is we want to know how much the user plans to tip. So again, with the encoding scheme for positional notation on this example, it's going to be the initials of the programmer, so CSF, I'm the one writing it. In example number 2, I'm making this on March 18th. It's the floating point number, and this is the second floating point number we're using. So obviously your variable names are probably going to look quite different than mine. Whatever your initials are and the date, at the very least, those are going to be different, right? You can see how we can encapsulate a lot of information in a relatively short string. And it looks very confusing, I know, but if you're working at a company that uses this, you'll get quite used to it, and then you won't read the whole string, right? If you just want the date part, your eyes are just going to jump to the date part of the variable every time, and you're going to ignore the rest of it. Or if you want to know which programmer wrote it, your eyes are just going to jump there. You'll kind of get used to reading a particular scheme. Unfortunately, we don't have that benefit in class because we just need to introduce it, and it kind of goes quickly. This next one I'm going to type in order. Typically, I'll write code the way I did this first one, which was kind of from the inside out. But this time I'll try writing it straight across. Either way works. Float, and grab some input. What percent do you want to tip? Then a space, just to make it look a little nicer, and then close our parentheses. So you can see either way works to type it. The main difference is you have to think everything through in advance typing it this way. You have to think it through and figure out what the computer needs before you type it. I like to kind of go in the order I think about it in, which isn't straight across like this. I think about it, when I'm thinking about this, I think I need input, so I do the input function. And then I think, well, I need to cast that input to a number, so I do these sort of things from the inside outward when I'm writing it. And then I jump around a lot in the code, but it flows out the way that I think about it. I don't have to do quite as much planning in advance to type it up that way. Now, as we saw in the plan, we're going to just assume the user gives us a number, a whole number for a percent. Say, they'll type in 15 rather than 0.15. But if we want to do math with 15%, we need to turn that back into a decimal. So, see, taking the variable I wrote, in example 2, on March 18th, that second floating point number, that equals that same variable. So I'm just going to copy and paste it. Control copy, control paste, and I'm going to undo this line in a moment. Divide by 100. And then that'll turn that into a variable. This sort of thing happens a lot. We take the variable, then we use that variable in the calculation for what it's going to be reassigned. It happens so much, in fact, that there's a standard abbreviation for this that works in most programming languages. So instead of saying our variable equals whatever was already in the variable divided by 100, I'm going to comment that out and retype that line to just say this variable wrote by Chris Francis in example 2 on March 18th, the second floating point number, do division assignment by 100. this is an abbreviated syntax that does this same thing. So the variable equals variable divided by 100 can be abbreviated to just variable divide equals 100. And that does that, if it's adding or subtracting, we call it increment or decrementing. I don't know of a good word off the top of my head for division, but that abbreviates all of this into this short line. And that is consistent in most programming languages, so you'll be able to use that again and again and again. So the next thing we need to do is figure out how much that tip amount is. So you're going to make a variable, and example 2, I'm doing this on March 18th, and this will be our third floating point number. Well, that's going to equal this tip amount we have. So our third floating point number is going to be assigned our tip percent. Oops. Control C to copy, Control V to paste. So our tip percent times the meal price, which is up here. Control C to copy, Control V to paste. Whew, this is getting to be a hard to follow mess already, right? So let's do what you're probably going to end up doing on the homework, and what you may do if you end up working for a company that uses positional notation anyway. And that is, let's develop our program with some nice variables and then put it in the proper format at the end. So when you're doing your homework, go ahead and give this a try first and see if you can follow it in positional notation. It's only showing up the first week, and basically we're just introducing it. But you're probably going to do something like this. I want to comment all this out, which we can do quickly in Python. We come up to Format and see up here, Comment Out region and Uncomment region, which is the keyboard shortcuts are Alt-3 and Alt-4. And so let's comment out the region. And with it still selected, I'm push Control Copy, come down a couple lines and paste that. And I'm going to highlight this, and I'm going to push Alt-4. Remember, that was the keyboard shortcut for Uncomment. To uncomment, push Alt-4. So Alt-4 will turn off all those comments. And let's make this a little easier to follow while we go through our example. So this, I'm going to call meal. This one I'm going to call tip. Might as well change these. So tip equals tip divided by 100 can be abbreviated into tip divide equals 100. Those two lines of code are saying the exact same thing, and this is a standard abbreviation that works in most languages. So now our price will be the tip. Oh wait, this wouldn't be price. Yeah, that'll work. Tip times the meal gives us how much to tip, right? We want to do this first. So I'll wrap that in parentheses. We'll find the amount that we're going to tip and add that to our meal price, to the original price of the meal. And that'll give us our total price. Total might have been a better word here. Let's change that. That's a whole lot easier to follow. So after this week with the positional notation, we'll be using this the rest of the semester. And yeah, you may end up doing this on your homeworks, and then we'll just change it to the form our variables need to be in when we get to the end. we still have the scheme there. And if you work for a company that requires you to use positional notation, you may end up doing it this way anyway, just because it's easier to follow. But positional notation is one of our standards. That's why I wanted to go ahead and do it. Make sure you give it a try before you just kind of do what we did here and go back to useful words and then change that. Because now it's a lot easier to follow, right? Our meal holds the meal price, the tip holds the tip price. We adjust the tip to a percentage, find the dollar amount for the tip, and then add that to the cost of the meal to get our total. And we're ready to print that out. So print, what's a good message? Your total today, maybe not today. Your total will be, I'll do it this way, $, plus, we saw in that first example, if we put in total, which is going to be a floating point number, plus today, period. That'll make a nice output. We saw in the first example, total is a floating point number, so we need to cast that into a string. We'll do it this way, and we'll come back and adjust this to a slightly better way to do this. So I'm going to hit Control-S to save this. Document, delete. What is this? Positional example 2.py. So with it saved, and run it, see if we got any errors in there. How much was the meal? Let's say the meal was $12.43. What percent do you want to tip? 15% is the standard, so might as well start with that while testing. Your total will be 14.2945. So kind of printed out right. That formatting's a little off though, right? By default it went to 4 digits, but there's a $sign right here, which means we should only see 2 digits. So another way when we format our numbers, a better way, instead of just saying turn that into a string, we also have a pre-built function, if I take this out, called format. And format is expecting 2 parameters, so we need to pass in 2 arguments. The first argument is the thing we want to format. Then arguments are always comma separated. So a comma. And our second argument is a string representing how we want it formatted. So set up a string, and we want a decimal place, a decimal, and then 2 spots after the decimal. And then we need to put an F to say we have a floating point number. So it kind of reads backwards. That's saying a floating point number that shows 2 places after a decimal. That's how we want to format this number. And that's a much better way than just directly casting to a string, because what we can see right here with dollar amounts, it definitely doesn't look like a dollar there. So let's run that. Control-S to save, then F5 to run it, and we can enter, well, I'll start with the same numbers. So $12.34 for the meal. What percent do you want to tip? Let's say 15%. And that looks more like a dollar amount, right? It gave us our floating point number to 2 decimal places. And when we do this, it does go ahead and round it. The standard, if the next digit's below 5, it just truncates it. If the next digit's above 5, it rounds it up to the next one. I might as well go and show this. See how this is going to get very cluttered very quickly. We can fill this up while we're testing things. I often like to just close the shell and then rerun it every time. So if we close the shell and come back over to our text editor and hit F5 again, it'll open the shell to run it. So how much was the meal? Let's say $22.95. So a decent meal. What percent do you want to tip? Oh, well, maybe there was great service today. So let's say 22% tip. Hit enter. Kind of rounds that out for us. It tells us what the total is going to be. Run it again. And we're going to test things regularly, right? Let's check a high dollar meal. It's like $74.83. $75.83. Expensive meal. Hopefully that's for a few people. How much do you want to tip? It was just impeccable service. You're very, very happy with the service there. So you're going to tip like, I don't know, 28%. And there we get our total. So everything seems to be working there. The last thing here, well, it started to get confusing, right? So we went through and adjusted that to useful variable names, but the requirement this week is positional notation. So we need to switch that back to positional notation. So I'm going to put my cursor right here before this part, and I want to change any place that says meal to something that follows our code. And I don't want to just go through and retype it every time. So the quick way in idle, and this one's kind of standard, is if you push Control, hold Control, and push H. So Control H brings up the Find and Replace dialog box. And that's not in all text editors, but it's Control H more often than it's not. CTRL plus the letter H to bring up this box more often than not. So we want to find anything that says meal and replace it with something that fits our requirement for positional notation here. So start with the programmer initials. So for me, CSF, Chris Francis wrote this. The class example number, well, for us, this is example number 2. A letter for the month. I'm writing this on March 18th. Y'all's date will be different, obviously. So M for March, and then 18. The data type and counter. So the meal price is a floating point, and it's the first floating point we encounter. So F1. So we're going to find all of those. Replace all. Set it. Fix all those. Now we can do that again. Control H. I'll put a comment in here to note that. It doesn't say. Control plus H to find and replace. Control H. So we're going to look for anything that says tip, and we're going to replace it with the programmer that wrote it, so written by Chris Francis. We're in example number 2. I'm writing it on March 18th, and this is the second floating point number we've used. So F2. Replace all. Got all those set up. How many more do we have? Oh, just total. So Control H. Replace total with the programmer, program number, date, and counter. So again, it's a floating point number, and it's the third one in the example. Replace all. So that should still work. So let's hit Control S to save it, and F5 to run it. Oh, kind of replaced the wrong thing there, didn't we? Just to put some numbers there to get to the end. This was still supposed to say meal. Oh, and I can see on the next line, this one was supposed to say tip. Those variable names were too useful to begin with. Now the prompts look good. We meet the requirement for positional notation on the variables. And yeah, you're probably going to end up doing that on your homework. But give it a try first, and then go back to the easier ones, kind of like we did there. So F5, how much was the meal? Oh, $17.98. $27.98. That works. How much do you want to tip? Let's tip 18%, and our total is $33.02. So just a couple things there to include, and just a note of when you're working with positional notation, you don't have to work with it. We can change it at the end. We can just get everything working and then adjust it to meet whatever requirements there are for naming things. I'm going to go ahead and make that point here. When I send out the example, I'm about out of time here. When I send out the example, I'll copy back the other one and add comments in and things. So let's go back to the board and get ready for the next example. So one last thing I didn't notice until I went to check the video is one of those variables got missed, and I thought I'd go ahead and show it on here. So if we go to File Explorer and go to where it's saved, I mentioned this point in the very first time we looked at Python, but it seemed like a good time to send a reminder about it. I saved them in here. So in this example, if we just double click on it, remember by default, it's going to open in the interpreter, give us some numbers, like 34, 22. It ended very quickly. It didn't wait on anything, but by default, it opens in the interpreter, which is what we want it to do. So you don't want to go changing that. So to edit it, make sure you right click on it, then edit with idle, or Notepad++, or whichever one. We go edit with idle, get back in here. And after making the video, I copied and pasted back that part we worked with, or when I add comments in before sending it out. But the problem was right here. I didn't notice until I watched the video again that that word total had been changed as well. So keep that in mind. When you're working with those, maybe try to do things that aren't in the prompts. That way when you come back and change them at the end, you don't have to worry about that. Might as well change this one as well, because that's kind of the working version, and then the version that meets the requirement for variable naming. And again, it only has to end with that way, kind of like the order we put it in, or when I do these input prompts, I express that I work from the inside out usually, and because it needs to end in that order. It doesn't have to be typed in that order. I find it more useful to not type it in the order it needs to end in. And kind of the same thing here. It's a whole lot easier to work with these variable names, and then change them to what they need to be at the end. It just has to finish this way. It doesn't have to go together this way, is the basic idea there. That positional notation in week 1 helps to express. That shows, as we do more and more coding, that general thought of it doesn't have to go together this way, it just has to end this way, is going to show up in more and more places. More and more places in the coding, kind of like the inside out thing that I do on these inputs. But I noticed that and wanted to remind you of make sure you open this by right-clicking and edit, or open the shell and go to File and open that way. You don't want to change the default of where it opens when you double-click. It seemed like a good place to remind you of that. All right, now let's go to the board and get ready for the next example. Yeah, I had a feeling that that positional notation wasn't going to stick around in the working versions for too long. And another point to make here, I don't think anybody in this class had me for SDEV 120, something I often say in the SDEV 120 class with pseudocode is like when people would turn in pseudocode for the assignment, I can always tell whether they did the program first or the pseudocode first, because I know for me, the only time my pseudocode matches the program is if the pseudocode was wrote afterwards. The only time they ever match is when the program was wrote first. I have a feeling this blue's not going to show up on the videos, so I want to redo this real quick. I remember when I was making the first video, even in the brighter daylight, the blue wasn't showing up so well. So here at night, it might not work. Yellow should show up. But those parts, there was an input for price, and an input for percent is what was going there. That should show up a little bit better in the video, and yeah, you can see that changed a little. Those kind of combined into one when we got over and did the code. But yeah, the only time, well, pseudocode, the only time my pseudocode is going to match the program is if the program was wrote first. So the plan is an organization. It's a planning thing. We don't have to stick with the plan when we put it into action. It can still modify. This is a getting ready thing, and practicing it now makes it a whole lot easier when we get to the big, complicated, more difficult problems where we actually have to do all this stuff. Then we know how to make a plan and put together a use case diagram and a state transition diagram and a data flow diagram and all those different, a timing sequence diagram. The different ones, we'll see them all eventually. It's a whole lot easier to learn them on simple examples, and then when we get to the complicated examples where we need them, we know exactly what to do. So got one more example for this video in mind. I'm going to erase the board and render this video down, and then we'll be back to make plans for that and then do a wrap-up. Our last example for this video is going to be a simplified payroll calculator. Just a very simple one. And as we sketch out the plan here, I want to accentuate a point that this is just for us. This point's going to be a mess. Think of that common Hollywood spoof of the character sitting in his office surrounded by scraps of paper that have been wadded up and thrown all over the office, right? That's a common Hollywood spoof. You've probably seen it, all the ideas that didn't make it. That's what we're doing here. So this part is going to be a mess. Think of, write it down on paper, wad it up, throw it away, write down the next idea, and, fill your office up with the discarded ideas. That's this step. So it's going to be a mess. It doesn't have to be nice. This is for us. This is for our benefit. This isn't the one the computer's going to run. At least not yet. Maybe someday the deep learning algorithms will learn to make sense of us writing a bunch of stuff on a whiteboard and type all the code up for us. And, the human just needs to make the algorithm for the computer to run. So payroll calculator, what do we need to do? Let's see. I guess the first thing we need to do is get it named. Then after we get a name, the second thing is pay rate. Pay rate, 3 hours. Find out how many hours they worked. That gives us enough information. After that, salary is pay times hours. 5 output. Just a very rough sketch of the idea. Practices at this point. Find out what works best for you. Maybe you don't need a whole lot of things, just something like this. One word on each step, except for this one. One word on each step to keep track of it, so when you get to the computer, you're ready to go. So that's kind of our plan when we get over there. Just a mess. Think of that Hollywood spoof wadding up the paper and filling up your office with the discarded ideas. Before we get over there, though, I want to talk about another UML diagram. UML data flow diagrams. And like the name indicates, this is just a diagram to show how the data flows through the program. So in this case, we have a couple of inputs. Name. Then as it goes forward, there's going to be a processing here in a second, but as it moves forward, we do another input that has the pay rate, which also going to kind of flow into this. And as it moves forward in time, we'll get another input from the user that has the hours. We'll figure out how much their salary is going to be. Very abbreviated. This will come over. The data is flowing this way. I guess I should put a start point. The program will start, forward an input. As time moves forward, we hit another input. As time moves forward, we hit another input down here. Goes over, do the processing. Then output some sort of string. Salary is whatever. Then we'll hit our dot. This is the idea of a data flow diagram. It shows how our information is flowing through the program. And the general idea here, this is called a fishbone schematic. You can kind of see how it flows out like the ribs on the rib cage on a fish skeleton. So a fishbone schematic is the general term for how we put a data flow diagram together. Let me go ahead and cover those. Those are very useful for understanding. And once again, doing it here when our programs are simple will be very beneficial when we get to the more complicated examples where we need this sort of thing to analyze and understand what's going on inside, to actually understand what the program's doing for very complicated, complex examples. Practices on the easy stuff. So let's go put this example together. Right? Mess around with stuff, experiment, find out what works best for you as far as planning and putting things together on the easy ones. That way when you get to the complicated ones where you need the plans, you already know what works for you. Let's jump over to Python and type up this example. And then we'll be back to wrap this up. Okay, so our last example today here is going to be a kind of overly simplified pay rate calculator. That's more just a calculation that we can use in these examples of basic input output, rather than formally doing all the calculations. Because we're not even near ready to do income taxes and overtime and things like that. We'll get to that soon. But just a super basic it's a calculation we can do a super basic input-output example with. So once again, we'll start idle, which searching for that just opens the shell, and we don't want to do it one at a time, so let's open the text editor to work with. Well, once again, this week's example is positional notation, but like we saw at the end of the last example, that's just how it has to end. It's not how we have to work with it. And in programming, the way it ends doesn't have to match the way it's developed. And in fact, it's better if it doesn't. When we're putting it together, we can work with the way we think about it, or do things easier to work with, in the case here, and then adjust it at the end to where it needs to be. Like follow our own train of thoughts, which means we'll be bouncing around up and down, back and forth as we put our stuff together. And just in the end, it needs to be in the order the computer needs to run it in. But we don't have to put it together from top to bottom. And same thing with positional notation. I tried to go as far as I could with the examples, and they got very confusing very quickly, right? It wasn't terrible on the one where we just took in a string and printed that string back out. But as soon as we tried to do a calculation with it, it was a bit overwhelming. But it's one of the standards, and particularly at big companies. You know, if there's like 50 programmers working on something, they're going to want to know who did what piece. So then it's fairly common that you'll submit your team part in positional notation, and that way the team managers can tell who did what part and go back to that programmer. They know who to go to as they're putting the major final work together, all the pieces together into a final project. And then at the end, they can change it to useful variable names afterwards as well. The key point is the way we put it together does not have to match the way it needs to end. So making up some sort of code here for us to work with. Well, this time, on the last two examples, I ended with a data type encounter. So trying to intentionally change this up, I'm going to start with a data type encounter this time. So I'll do 3 letters for the data type and 1 digit for the counter, which will be enough for this. In a larger project, might need more than 1 digit for a counter, but for this example, 1 digit will work. Let's do example number again. So E, then the digit for example number, which this is example 3, so all of these are going to say E3 on them. And I'll do programmer initials again. So I just made a point about on large teams, 50, 60 programmers all doing different pieces, it gives a way for the project manager to tell who did which piece as the final complete version comes together from all those pieces. Is one of the common places you will see positional notation used. It shows up a lot in IT because, as mentioned earlier, we can store a whole lot of information in a fairly short alphanumeric string. So that is how it needs to end, because this week there's a requirement that everything has to be in positional notation. But not how we're going to develop it. We're going to develop it with some more useful words, and then we'll just change them at the end. So as we saw in the plan a moment ago, first thing we need is an employee name, and I'll just do camel case. That way when I go to change it, it's not going to mix in with other words. Try to make sure that doesn't happen again like it did on the second example. Well, employee name is going to be a string, so we don't have to do any casting. We can just get an input and bring that in. I'm going to add a comment here because we haven't done that yet. Add a line comment that says imp name. Eventually this line will be changed and have a different variable here, right? Might as well do a single line comment at the end of the line to say what that line's doing. some documentation to it. And then just a prompt. Give me a name. I'll do a cheerleader prompt this time. Next, we want to know that person's pay rate. So, well, I can do pay rate as one word because when I put it in the prompt, it'll be 2 words. And I'm going to do this in order I think about it. So the first thing I think is I need an input. And I've got a line comment here at the end that says this line does pay rate because there won't be a useful variable name when we get to the end. So some sort of input prompt. What's plus name plus pay rate. So we're going to have the employee's name at this point. So we might as well work that in and make that specific with the prompt. And this is why I made that point earlier about concatenating our strings rather than using that multiple arguments in the print function, because that only works in the print function. If we want to build up a string in an input, we have to use concatenation. So that will get our pay rate. The pay rate's probably a floating point number. So the way I like to do it, working from the inside out, then we need to come outside this and turn that string the user gives us into a floating point number. And the last thing we'll need to get from the user is going to be the hours worked. I'll just do it in camel case. Oops. Hours worked. And again, I'll do it from the input inside out. So we're going to ask for an input. We'll go ahead and get that set up and add a comment here at the end. That way when we go back to the required positional notation on the names, we'll have a comment saying what that line is to refer to that variable when we see it. And sort of the same thing. How much did concatenated with employee name work? Oh, I want to put a space in here. Just make it a little nicer. Instead of saying how much, I just want to be as specific as possible. How many hours did employee name work? So say we have somebody named Bob. How many hours did space Bob space work? And just to include in the example, I'm going to assume we're only working an integer number of hours. So it's got to be a whole number. And there's something related with this, and I'll show you. Oh, that line passed the edge of the screen, right? So there's this nice thing in Python we can do to break this up. If we use a backslash and then hit enter, that'll treat that as one thing. It just kind of breaks it up. Whoops, I think I've got that a little off. Let me hit Control Z to undo that. The backslash needs to go after the plus sign. So how many hours, concatenate that with a line break in our thing here. That's just a quick symbol that tells the Python interpreter that this instruction continues on to the next line. How many hours did so-and-so work? That way we can fit everything on one line nicely. So now we could just go ahead and print this out, right? Print and all that stuff in there. But the last point I wanted to make in the examples for this week has to do with the output like that. We saw concatenating things. You can see here, it can get start to look a little messy at times, right? So a better method, just as far as cleaning up the code goes, is to build a string and then output that string. So what I want to do here is I want to build up an output string. Output string is going to start as a blank string. I'll put a comment in here to that effect. Build an output string. And now we can just basically concatenate pieces onto this string rather than doing it in one line, spread it out over a few lines just to make the code look a little nicer, easier to debug if we have to come back and fix problems. So then we'll take output string, concatenate assignment. So when we have that shorthand, that's so output string equals output string concatenated with some words. But that happens so often that there's an abbreviation for it. And we have, well, with the string, it's going to be the concatenation assignment. So output string, concatenate assign, what's going to be first here? Maybe the employee's name. So I'm just going to make one up to talk about this. Say, we want to say something like, Bob made so many dollars this week. Kind of the string we're looking for here, right? So this represents the employee name. And this is, I'll call it salary for now. Those are our variables. Make up an example of what I want this to say. We want to go for this string. So the first thing we need is employee named. So our output string is the concatenation assignment to employee name. Then output string concatenation assignment again. And we're going to add in a space, the word made, a space, and a dollar sign. That's this next part. So a space, the word made, then a dollar sign, and no space after that because we want the salary to go right afterwards. And then kind of do this again, right? Output string plus equals, well, now we're ready for the salary, which we don't really have yet. We'll have to calculate, but that's just going to be pay rate times hours worked, which if we multiply a floating point number times an integer, it's going to return a floating point number. But we need a string in order to concatenate it here. So we saw earlier, we could just cast it into a string, but we probably want to cast it into a formatted string. So we're going to format whatever value that is then our second argument is the format we want. So we want, it's money again, so we want 2 places after the decimal on the floating point number. And remember that little string goes backwards. So that's saying format a floating point number to 2 places after the decimal. And then the first argument is the number being passed in. And notice that I didn't save that value to a variable. We can do the math right in here. We can do the math in the middle of concatenating a large string if we want to. This is just a way to make it look a little nicer. Makes it easier to work with, go back and fix problems. Because if there's a problem, we can immediately go to where the problem is and not have to kind of narrow it down quicker. Made this much money this week or this pay period. Whoops, that should be a string. Then after the salary, we need a space, and maybe this pay period is a better way to say that than this week. Not everybody gets paychecks week to week. But the idea there is rather than concatenating and output all in the print statement, we go ahead and build up the string in this nice organized format. It makes it a whole lot easier to work with and makes the code look a little bit cleaner. Then we can just print that output string. So I'm going to hit Control S to save it. That last line is just print output string. Might have saved a little quicker. It will be there. So what is this? Positional example 3.py. Well, this needs cleaned up still, so I'm going to take out some of that extra white space. So F5 to run it. So give me a name. I kept using Bob in the example, so I say Bob. What's Bob's pay rate? Maybe Bob makes $9.55 an hour. How many hours did Bob work? Let's say Bob worked 21 hours this week. $200.55. Oh, that sounds reasonable. Maybe do a check on one that I can do the math very quick. We can do the math a little quicker for. So let's say Sally makes a nice $10 an hour. And Sally worked 10 hours, so Sally should make $100, right? Sally made $100 this pay period. You always want to check something, go to a calculator or pick numbers that you know what the answer is going to be to make sure it's doing the math correctly. But the main thing I wanted to bring up here was this nice organizing the code to create a string here. So it seemed to work. And the last thing for this example is back to that. The order we develop it in does not have to be the order working towards the final order. It's better if we don't start at the top and just write lines of code top to bottom right in order. We want to work with the way that our brains think. It'll flow out better, which means we'll have to move around and do some back and forth, and then the final version needs to be something different. So in this case, we still need to change these variable names. So I'm going to select all that and hit Alt-3 to comment that. And with it still highlighted, I'll push Control-C to copy, come down a couple lines and paste that. Then I'll uncomment this one. Alt-4, uncomment. And now once again, I want to push Control-H and change all of these variables to match our naming requirement. So we have this variable imp name, which was useful for developing the code, but we have this requirement that we need to say what the data type is. So employee name is going to be a string, and a counter, that's the first string we used. We're on example 3 here. And this one, at least in my case, was written by Chris Francis. So you can see there's a lot of information that can be encoded in positional notation. So especially if you're working on a large team, it can be quite useful. You might have a requirement like this, but you don't have to develop it in that way. It just has to end in that way. So go ahead and replace all those. So what's next? Pay rate. So Control-H. Look for anything called pay rate and replace it with, well, pay rate is going to be a floating point number. We're in example 3, and at least the one on the screen here was wrote by Chris Francis. So obviously yours is going to look slightly different. You have, well, I don't think anybody in the class had the same initials as me, so yours is definitely going to look different if you're following along. And replace all those. The hours worked. Control H. Then look for a variable called hours worked, which is going to be an integer in example 3 written by Chris Francis. So that's what our variable needs to look like. So replace all. Now it's in the required format. So we'll run it to make sure it works, but the key points here were splitting up the strings. So in Python, we can just throw in a backslash, and that just tells the interpreter that this thing continues to the next line. We're in out of room, and just come down here and continue. And the code can look a whole lot better. I need some space to scroll here. There we go, bring this up near the top. The code can look a whole lot better if we build up our strings rather than trying to pass them in directly. We can do the same thing on our input strings, right? Build up an input prompt and then pass that in. Oh, whoops. That's a variable that needs changed. So better do that. Control H. Change output string to, well, as it says in the name, it's a string. This is the second string we've used. So string 2 in example 3 written by Chris Francis. And positional notation is great for encapsulating a lot of information in a very short string. So I'm going to save this, run this, give me a name, David. Oh, David makes $19.34 an hour. Pretty good pay. And he worked, the full 40-hour work week. Not a terrible paycheck for a week. But that's the key points here. The breaking this up, just tell the interpreter to go to another line, and then build up your strings. Building up your strings can make your code look a whole lot nicer. And if there happens to be a problem, you can go address that problem in just that particular line. The same thing can happen on the input strings. And it adds a few lines, but it makes the code look a whole lot nicer and easier to follow. Easier to follow and to work with and all that stuff. So let's go back to the board, wrap this up. Okay, so that kind of wraps up our examples for this week. Hope all that makes sense. Oh yeah, I wanted to mention, in case anybody was wondering, let's try to do this without it being too loud, hopefully. I use, if you saw the blue dot, the blue dot flashing on my neck, I'm using these kind of microphones, the ones that normally go with phone calls. They're very comfortable. The necklace type microphone, necklace microphone headphone things. Just in case you saw that blue dot flashing and were wondering what that was. It's the microphone I'm using here. So wrapping up, that's kind of the examples we have for this week. Some of those concepts, hopefully all those concepts make sense. And this one, yes, I will definitely agree. Anything that fits in the time constraints of a classroom can be done without a plan. Especially this stuff here at the beginning. These are easy examples. We should, shouldn't be much trouble to sit down and make them. But planning them is really easy as well, right? If it's an easy example, it's an easy plan. So this is the place to learn to make a plan. And that way when we get to the hard examples and hard programs, later in the course or future courses or in your working career, you know how to make a plan. And you don't have to figure out how to make a plan when you actually need it. Planning is really easy at this point. So practice it, figure out what works for you. Kind of a personal thing, I mentioned the Hollywood spoof of a writer sitting in their office just with the room covered of the papers they've discarded, wadded up and thrown all over the room, the discarded ideas. Keep that in mind. That stage is important. There's a reason why Hollywood does that spoof so often. And make the plan at this point. And follow along the examples. I'll say it again, programming is a problem-solving thing, so we have to develop our problem-solving skills. And that takes practice, which means following along the examples from the videos here, or in the textbook, or hopefully in future semesters back in the classroom. And something I always did that I thought was really helpful is I always tried to do something similar to the example. So in class, instead of typing exactly what I type, try to do something very similar to what I'm doing to make sure you get the understanding, not the exact syntax. Because it's a problem-solving thing, and every problem is a new problem. What we've done before might be helpful, but it might not. So we have to develop those problem-solving skills. Or in the textbook, when you're reading along and you get to a point where, like this, the textbook author decided, okay, you're ready to put together a payroll program. And there's an example coming up in the textbook of a payroll program. Well, instead of copying that directly, because you want to practice the example, obviously, you see it's a payroll program. If you have a basic idea of how to do that, go to the keyboard and try to make your own. And then if it doesn't work, then check the example in the book. And work on practicing and developing those skills at problem solving and putting algorithms together. And obviously, even just directly copying helps too. Whatever works for you. Every one of us, we're unique individuals. We're going to think different. So you're going to have to experiment with different things, different ways of making plans and organizing your thoughts, and how figure out what tools work best to help you understand what is going on in a particular program. That way, if you need to do something similar on a problem in the future, you have an understanding of what solves the problem, not just memorize the syntax of what worked on one particular case. So develop those skills. Practice those problem-solving skills, not necessarily memorizing the syntax. That's what we're looking at here. And yeah, so these videos are going to come out a couple times a week to take the place of the lectures. I kind of abbreviated. When there was going to be a 2.5-hour class of this, there was a couple more of these examples, but the last couple didn't really add anything new, just reinforce these things, so the concept should be there. And yeah, so these videos will come out a couple times a week at our regular scheduled time. We'll be having a Zoom meeting where we can interact. FaceTime is a more common phrase for that. It's office meeting software, call-in software, with some sort of interaction where we can address questions and discuss things. We'll have those and put out these videos, so covering the concepts. The next one's probably going to be a lot of concepts about software development, and then we'll follow that up with examples and kind of alternate it that way. Concept, examples, to kind of break it up. But just have to see what works best. I might have to do something about the lighting for when I shoot these videos at night. I'll have to see after I render this down. But as long as you get the general idea of what's on the board, like this one in particular was just about planning, rough sketches. This part gets messy. Let it get messy. Whatever works best for you for putting plans together. And practice that now while the plans are easy. That way, when you get to hard things, you know how to make a plan. You're well practiced at it. As well practiced as you will be at typing up the codes. So I guess that's it for tonight, and I will see you all at the Zoom meeting on Monday and Wednesday, our regular scheduled time, 6 o'clock on Monday and Wednesday. See you then.